In this video, we're going to take a look at what's called the box model. The box model is a framework for understanding how HTML elements behave like boxes in the layout of a page, and this is determined by a set of related box model properties within CSS. Before I go on, I just want to remind you that this video is interactive, so if at any point you want to, you can pause the video and directly interact with the code within, or you can copy and paste that code out into your own editor, and then when you hit play again, it'll just pick up where I left off. Let's take a look at what we have here. I have a basic HTML page set up, and I have a number of elements. I have an H1, several paragraphs, and the last paragraph is inside of a div. And if we look in the browser to see how these items are behaving, we can see that they just stack one on top of the other. And this is how block elements behave by default. They stack like blocks. Let's dig in a little bit more. If I go into our CSS, and I'm going to select for the H1 and the paragraphs, and I add a background color, we'll just go for a nice light salmon. And then when we look at this in the browser, we can see that these background colors extend all the way across the space available within the parent. In this case, all these items are contained within the body, so this stretches all the way across the body. It's important to understand that this box is here at all times. We're only making it visible by applying a background color. It's important to understand that block elements extend all the way across their parent container and fill up the space that's available horizontally, even if there's not enough text to stretch all the way across. We can see that there's a little bit of space between these items. That's just because the browser provides some default margin or space between these elements by default. If we wanted to, we could just get rid of that margin by zeroing it out, and all these elements will just stack right up against each other. I'm going to go ahead and add in a little bit of margin so that we can differentiate these elements visually, but we'll talk a bit more about margin a little bit later. Now, as I said, by default, block elements span all the way across the parent or the space available. We can actually control this if we want to by adding a width to these elements. And we'll just mess with the paragraphs for now. Width 400 pixels. We can see that the paragraphs now span exactly 400 pixels wide. And that's going to be an absolute unit. So if I shrink down the browser, then we can see the 400 pixel wide boxes hang out the side of the browser window, and I get a horizontal scroll bar. We can, of course, use other types of units. So we can use percentage units, which can be pretty handy sometimes because they give us a fluid layout. So now the text is going to reflow and the boxes are going to shrink or grow to be exactly half the width of the container. And this is pretty good, but as you can see, it doesn't allow us to limit the line length of the text. And as we've talked about in our text videos, sometimes it's desirable to be able to limit that line length so that it doesn't grow too big. We can also, of course, control height. Normally, a box is as tall as it needs to be to contain the content that's within it. So you can see this first paragraph right now is 3 lines tall. So the box is tall enough to contain those 3 lines of text, whereas the second paragraph is only 2 lines tall. So the box is only as tall as it needs to be to contain those 2 lines. But of course, I can manually set a height. So I can say height 10 rem. And now we can see those boxes are 10 rem tall, no matter how much content there is within them. We can also use other units, pixels or whatever. It's important to note a small thing is that percentages will not work on the height axis. And the reason for that is that there is no determined height of the body. It just grows to be however tall it needs to be depending on the content. So usually height will not have any effect unless the parent of the item has a specific height applied. So best to avoid using percentages for height. Now, most times we don't want to specify a height. We just want the amount of content to determine how much height there is, because it's hard to be sure how many lines of text you're going to have in something. So to make sure that you don't have any problem with text hanging out, it's often best to let height work itself out. And we can just give a quick example of that. If I put a really low number for height, if I say height 20 pixels, then we can see that there's so much text that it hangs out of the box we have described and you get weird overlap. So that's exactly why you often want to just let height take care of itself and be automatic. But with width, as I said before, if we use an absolute number like a pixel number, we might have an issue with our boxes being too wide for the browser width. If we use a percentage, then when the browser's really wide, our box might be wider than we want it to be. So there is a solution that goes beyond either of these. We can use a modifier to width. We can use max dash width. What's great about that is that means never let the box be larger than this. And you can see the box doesn't ever get larger than 30 rems wide. But if we shrink the browser below 30 rems, it does allow that text to reflow and the boxes to be smaller. So for a lot of cases, you just want to set a max width, and that allows the browser to contain all the content when it's less than 30 rems, but stops it from growing wider than we want it to. Of course, the inverse is also available. We can use min width, and this means never be smaller than this. So this will just keep growing with the browser as long as the browser is wider than 30 rem. But if we shrink the browser below 30 rem, we can see that the boxes no longer shrink. The use cases for this are less, but it can still be helpful to know it exists. Now, by the same token, we can do max or min height as well. So min height to rem. So that means that the boxes must always be at least 2 rem tall. If we say max height 2 rem, then that means that the boxes will never be taller than 2 rem. And you can see this first and third box, we get some text overflow because they have to hang out in order for those boxes to never be taller than 2 rem. Again, the use cases for this on height are fewer and farther between, so I tend to just let height work out itself. But again, it's useful to know that those possibilities exist. Okay, I'm going to take max width off of here and let this go back to just calculating itself. We just have the automatic width and the automatic height governing the size of our paragraphs. The next thing we can do is add padding. Now, what padding does is it adds space inside of a box between the box's edges and its content. So the content of our paragraphs is the text. So if I add padding, I'll give them 2 rem. And so by using just one number here, that puts 2 rem all the way around the box. So I can see that the boxes have actually grown on the vertical axis by a total of 4 rem. We've added 2 rem on the top and 2 rem on the bottom between the edge of the box and its text within. So therefore it has grown by a total of 4 rem. But on the horizontal axis, there's no place for it to grow to. It's already as wide as it can be, as wide as the body, its container. And so what it's had to do on the horizontal axis is push the content in by 2 rem on each side. So it couldn't grow horizontally. So it's important to know that if a box can grow, it will take up more space to accommodate the padding. But if there's nowhere for it to grow, it will push the content in to accommodate the padding that we've added. Let's also briefly talk about directions. I just provided one side, and that put padding all the way around. It's important to know that I can do this on individual sides. So padding is actually a shorthand. I could also just type padding top 2 rem. And if I did that, we're just going to get padding on the tops of the elements. I could also do padding bottom, padding left, padding right. Let's just try that out. Padding bottom. And you can see we've got some padding on the bottom, and you can imagine the others. So just padding with no side attached to it is a shorthand for padding on all sides. But we can also, within that shorthand, we can control which sides get how much padding. So if we do 4 values, because there are 4 sides, let's say I say 2 rem, 1 rem, 1 rem, 3 rem, you can think of this 4 value shorthand as the 4 cardinal directions on a clock going around clockwise. So it starts on the top, gives us a value for the right, the bottom, and then the left, just like if we were going around clockwise around a clock. So top, right, bottom, left. And we can see that we've got 2 on top, 1 on the right, 1 on the bottom, and 3 on the left. That's a great way to control all the sides at once with just one line of code. We could, of course, use 0 values if there are sides where we didn't want any padding. So now I've got 2 on the top, 1 on the right, 0 on the bottom, and 3 on the left. And we can see there's 0 on the bottom. But we can use an even shorter shorthand if we don't need to be so explicit. So if I give just 3 values, the way this is read is a value for the top, a value that's shared by the left and right, and then a value for the bottom. So here we have 2 rims on the top, 1 rim on the left and the right, and 0 on the bottom. We can go even shorter if we don't need to be as explicit. So we can do just 2 values. In the case of 2 values, we have a value for the top and the bottom shared, and a value for the left and the right shared. Top and bottom, left and right. So 2 rim on top and bottom, 1 rim on the left and right. We can see that's what we have here. And then, of course, we can go back to just a single value that will govern all sides. Now, another thing that's important to know about padding is that it is there and inside the box whether or not there's a background color. So if I remove this background color, we can see everything looks spaced out because that padding is making the boxes bigger. So even though everything looks spaced out, it's actually that the boxes are bigger still. The boxes are just invisible. And if we add that background color back, then we can see that those boxes are there. So that's padding. And I briefly mentioned earlier about margin and how there was some default margin spacing these boxes out. And I put some margin up here on everything. Well, let's go back to that. Margin is space between boxes. Padding is space inside a box between its content and its edges. Margin is space between boxes. So a good way to think about padding is it's like the packing peanuts inside a box that you're shipping out. So let's say you have some product and it's being shipped to you. Often you'll have packing peanuts inside the box between the edge of the box and the actual product. And that's like padding. Margin is the space between boxes. So maybe you put your boxes on a shelf, but you don't have them touching each other. You've got them spaced out. That is margin. And let's take a look. Because we put 1 rim of margin, we can see that the boxes are spaced out 1 rim from each other. There's a funny phenomenon with margin where margins try to collapse together. Because there's 1 rim of margin on the bottom of the H1 and 1 rim of margin on the top of this paragraph, you don't get a total of 2 rim. They collapse together, so you get just 1 rim between them. This can be a little tricky sometimes, but if you know it's there, you can be aware of it. Notice that, again, more space has been added. If we set our margin to 0, we can see that our H1 is right up near the top of the box. And we can see that the left and right is right near the edge of the browser, right where the edge of the body is. But if we change that back to 1 rim, now by giving 1 value, we set 1 rim on every side. We can see that the first box has been pushed down by 1 rim. So just like with padding, if there's space, the margin will push the boxes down and cause the total height to grow to make space for that margin. But on the horizontal axis, there's nowhere for the total to grow to. So the boxes get pushed in because they have to shrink to accommodate that extra margin that we've added. Let's make this more dramatic again by changing it to 3 rim. We can see each of the boxes is pushed down farther to accommodate that horizontal margin because there is a place for it to go. It can go down the page. But on the horizontal axis, the boxes actually had to get smaller to make room for that margin that we've added on the sides. Now, just like padding, margin is a shorthand for margin top, margin right, margin bottom, and margin left. So we can write margin dash left and only get margin on the left side of the boxes. We can write margin dash right and only get margin on the right sides. And same thing for top and bottom. Going back to the shorthand margin, as I said, if we have just 1 value, it will be applied to all sides. But just like with padding, we have the same shorthand opportunities. So we can do 2 values. If I say 3 rim, 1 rim, the first value is applied to the top and bottom. The second value is applied to the left and right. So we can see we have lots of space, 3 rims on the top and bottom, but we only have 1 rim on the left and right here. If we do 3 values, 3 rim, 1 rim, 5 rim, so that's top, a single value for the left and right, and then bottom. Top, left and right together, bottom. So now we have 3 rim on the tops, 5 rims on the bottoms, and 1 rims on the left and right. And then if we do 4 values, that's clockwise around the clock face, starting at the top. So 2 rim, that means 3 rim on the top, 1 rim on the right, 5 rims on the bottom, 2 rim on the left. Top, right, bottom, left, circling around a clock face clockwise. So I'm going to set this back to 3 rim. Now, it's important to know, again, padding goes inside a box, margin goes outside of the box. If we get rid of the background color, you can't tell the difference between the two. You can't tell how much space is coming from the margin and how much is coming from the padding. But it's important to know that there is a difference. The space that's applied to the boxes themselves is from the padding. The space between is from the margin. They're not the same thing. So I'm going to add that background color back in. Okay. The next property that is a function of the box model is border. If we can think of padding as the packing peanuts within a box and margin as the space between boxes on a shelf, then border would almost be the cardboard of the box itself. It would be the visible edges of the box. And that does get calculated into the size of the box. So I can say border, but we're going to need to tell the box a few things about the border to make it work. So the first thing we need to tell it is how thick we want the border to be. I'm going to make this 10 pixels. This will be a good thick border. And I can, of course, use rims or any other unit I want to. Then I need to tell it a style. So I can say solid, I can say dotted, I can say dashed. And these two values alone are enough to make the border happen. I have just used the border property, which is a total shorthand, meaning this gets applied to all sides. Just like with padding or margin, we could do border on just one side, but let me show you how this looks. So now we can see we have a solid border that is 10 pixels thick on all sides. Let's dig in just briefly to the style of the border. So we looked at solid. We could also do dashed, and here we get this dashed border. We could also do dotted, and dotted is going to give us little round dots. You're probably going to use solid maybe 90% of the time. For the remaining 10%, dotted and dashed are going to make up the rest of that. And then there are other more exotic values like inset that probably get used pretty rarely. I'm going to go ahead and go back to solid. Now, there's a third value that we can apply to this shorthand. By default, the borders are the same color as the text. So the text is black by default, so the border is black. If I make the text a different color by setting a color value, the border is going to be blue because the text is blue. But we can manually override that. I can set a color on the border itself. So I can say 10 pixels thick, solid style, red, and then the border will be the color that I specifically told it to be. So you can do just two values, width and style, and it'll be whatever the color of the text is. But if you add that third value for color, it'll be whatever color you told it to be. As I said before, border is a shorthand, and it's a shorthand in a couple of different ways. The first is, like padding and margin, it's a shorthand for sides. So I can just say border dash top, and that border will only be applied to the tops of the boxes. I can say border dash left, and those borders will only be applied to the left of the boxes. But it's also a shorthand for these different properties that we stacked onto here. So instead of writing it this way, I can write border dash width and provide a thickness. And then I can do border dash style and give it a style. And those properties will be applied all the way around. I can also, of course, do border color, and that will be applied to those borders. And we can get even more granular. So we looked at how to shorthand for the sides. We looked at how to shorthand for the different sub-properties within border. We can get even more specific, and we can do border left color. So that's going to apply that color only to the border on the left. If we say border left style and border left width, then we get all those properties on the left. Border is a shorthand in the sides and the individual sub-property, and you can break those out to as specific as you wanted. We could say border right color, border right style, border right width, etc. But usually I don't use the individual sub-properties. I will sometimes use just a border on a side and use the shorthand for that. So border left, 2 pixels solid, blue violet, but I very rarely reach for border dash width or border dash style. But that's a personal preference. You can mix and match these any way you want to. And it's also important to know that border is part of that calculation of the size of a box. Now, there are a few caveats here. We've looked at the main properties, but there are a few things that can go a little bit weird. I'm going to get rid of the border. We've got this padding of 2 rem. And as we said before, the box has to shrink down to make space for that 2 rem if there's no more space inside the container. So in this case, if there's no more space inside the body, the padding pushes the content in to make room for that padding. But what happens if I combine this with a max width 50%? What would you expect to happen? You might expect for the total width to be 50% with 2 rims pushed in from 50% on the left and the right. But that's not actually what happens. You can see that these boxes are clearly wider than half the space available. And the reason for that is that we have a width of 50% being applied to the content and then 2 rim being added to that on either side. So the total width of this is 50% plus 4 rim. And that can make things a little awkward because maybe I wanted these to be exactly half the width so that I could have a split layout of some kind. This is the default behavior. When you add padding or add border, it gets added to any explicit size that you said. This can sometimes make sense, but sometimes it's not really what you want. So there's another property that allows us to control this. It is called box sizing. And if we set a value of border box, basically that tells this to behave how I want it to behave, which is to put these 2 rim on either side inside of the 50%. Now we can see that these boxes are clearly actually half the width of the container, and those 2 rim are placed inside that 50% and push the content in smaller to make room for that padding. This is border box. Now, border box is so great, and it's so often the way that I want things to behave that I've sort of decided, you know what, I just always want all my elements to be border box. So what I'll often do is add at the top of every CSS style sheet a star for a selector, an asterisk. And what an asterisk means is select every single element there is. And then I add box sizing border box to that. So this is telling every element to behave as the border box style. And now I can see that these paragraphs are indeed half the width of the container, and it's behaving in that border box fashion. When you have certain things that you like to put in every CSS file at the top to kind of get everything just how you like it, this is called a reset in CSS. So I will usually set up a little section using comment blocks to organize my CSS, and I just call that reset. And I usually make this reset the first thing in every single CSS file. And then I use comment blocks to break out the rest of my CSS into similar sections. So I might say layout or something like that. So that's box sizing border box. It's a really helpful tool. Remember in our HTML, we have this last paragraph inside of div. One thing we haven't talked about yet is the way these box model properties can affect each other. We've just been looking at these elements as children of the body element. But what happens if we apply some of these box model properties to the div? Well, let's start out by giving the div a background color, light blue. What happens if we take these properties away from the paragraph? So we don't have any margin or padding or width applied to the paragraph. We don't see the background color of that div at all because it doesn't have anything to push it away from the edges of the paragraph. So it's behind there. We just can't see it. So if we add padding to the inside of the div, what do you think is going to happen? 2 rem, and because I'm using one value, that's 2 rems all the way around. Now it pushes the edges of the div 2 rem out from the edge of the paragraph. And notice on the left and right, it has to push the paragraph in to make room for that padding. If I were to add padding back to the paragraph, what do you think it's going to do? Notice that we get one rem of space between the edge of the paragraph and the edge of the text, but we still get our two rems of space between the edge of the div and the edge of the box for the paragraph. So you can kind of start to see how these things interact. Now, there's too many scenarios of how different boxes might interact with each other for me to go through each one individually. But it's important to start thinking of how they might interact with each other. And you can do your own experimentation on that. So that's the box model. There are a lot of things here and a lot of ways they can interact, but just briefly, it includes the way boxes flow by default. Block elements stack, inline elements sit next to each other, as do inline block. If you add width or height, or max width or min width, or max height or min height, it controls the width and or height of the box. If you add padding, it adds space inside the box between the box's edge and its contents. You can use shorthand for that. If you add margin, it adds space outside the box between the box and whatever box is next to it or above it or below it. And you can use shorthand for that as well. There's border, which adds a visible edge to the box. You can add a border thickness, a border style, and a border color. And that is also a shorthand both for border on the different sides and the individual border properties, width, style, and color. There's box sizing, border box, which allows you to make sure that padding and border get added inside of a specified width for a box instead of added in addition to it. So there's a lot there to consider. I'll see you in the next video.